When we say the body is elastic body is a body that regains its shape after the application of force or load. Elastic bodies are bodies that regain their shape after the application of what? Load, or we call it force. Elastic body. Elastic body is a body that regains its shape after the application of force, or we call it load. Elastic body. Example of elastic bodies. Example, we have a rubber band, spiral spring, spiral spring. These are good example of elastic bodies. Rubber, spiral spring. They exhibit this process. So the ability of a body to regain its shape after the application of load is what we call elasticity. Elasticity is the ability or the tendency of an elastic material to regain its shape after the application of load. So let's put it down. Say elasticity is the ability of an elastic material to regain its shape after the application of load, or we call it deformation, after the application of load, or you call it what? You can call it force, anything, or you call it deformation, after deformation. So there are bodies that have this capacity to regain their shape after the application of load is called, they are called elastic body. So that ability, that tendency which some bodies possess is what we call elasticity. Are we together? So this concept of elastic bodies, you understand, this concept is governed by a very fundamental law propounded by Hooke's. And Hooke's is governed by what? A fundamental law in physics. They call it Hooke's law. Hooke's law explains the elastic tendency of bodies. Hooke's law. What did Hooke's law say? Hooke's law says that provided the elastic limits of an elastic material is not exceeded, provided the elastic limit of an elastic material is not exceeded, the extension of the material, you can put it at the extension E of the material, is directly proportional to the force or load applied. Is proportional to the force or load applied. That the extension is directly proportional to the load applied. That means the more the load or the more the force you apply to an elastic material, the more the material will increase in size. Are we together? So let's see how we can put this law in a mathematical form. So we say F here is 30E. So this sign F here is the force or the load, E here is the extension, where this sign here is the sign of proportionality. So we can rearrange this expression. We say F is equal to what? KE, where K is the force constant. K is called the force constant, where F is the force, E is the extension measured in meters, force is measured in Newton, then K is the force, our force constant. Our force constant is the same thing as K, which is equal to F all over what? E. So the SI unit is what? Is Newton per meter. SI unit of our force constant. SI unit is Newton per meter. So that is what we have in there. We talk about Hooke's law. This law is a very fundamental law. It explains the properties of elastic bodies. It explains the properties of elastic body. So let's move further and look at another concept. We call it the Young modulus of elasticity. The Young modulus. Young modulus of elasticity. What did Young modulus tell us? Young modulus says that Young modulus. It says that E represents the Young modulus. It says stress per what? Strain. Young modulus is defined as stress per strain. Stress per strength. So if you say Young modulus is defined as stress per strain, what is stress? What is stress? You say stress. Our stress is the same thing as what we call the pressure. So and it's called force per unit area. Force per unit area. Our stress is what? Force per unit area. Which you can put it down and say F all over what? A. And stress is measured in Newton per square meter. It's measured in Newton per square meter. That is our stress is measured in Newton per square meter. Are we together? So let's look at strain. Strain. Our strain is expressed as what? Extension per original length. Original what? Length. So you can put it as E all over what? Original length, you can use L naught. So strain is a dimensionless quantity. Why? Because it's a ratio of what? The length, the ratio. Extension is measured in meters. Original length is measured in what? It's measured in meters. So strain is a dimensionless quantity. So if we put this concept, this strain, back to this our equation X here, we call this one equation X. That means our Young modulus, which we call E, is force per unit area divided by E over L naught. That's what we are. So if you put it, it's the same thing as F over A divided by E all over L naught, which is equal to F over A. When you change division to multiplication mathematically, you invert for the divisor, become L naught over what? E. So our Young modulus is F L naught over A what? E. So you can use this to represent our Young modulus of elasticity. Young modulus of elasticity. So this is Young modulus of elasticity. You can use it to solve problems concerning Young modulus. So that is Young modulus. So we'll talk about elastic bodies. Then we talked about elasticity. We look at Hooke's law and we explain the concept of Young modulus of elasticity.